Good morning for most of you, maybe, or a good afternoon. My name is Ben Ramseth, and I am an instructor here at ESRI. Joining me today is Marnie Taggart, a senior instructor here at ESRI. Marnie will be helping out answering some of the questions you send in. So, let's get going on working with Geodatabase Topology live training seminar. So we should first talk about our seminar overview. And we're going to talk about three topics in this seminar. The first topic will be Geodatabase Topology Basics, followed by a very short demo, and then we'll have creating a topology and setting rules, followed by a demo, and then editing geodatabase topology, and then there'll be a longer demo where we actually go in and edit some topology. So the format, as I've kind of alluded to, will be each topic followed by a software demonstration, and then we'll go into a quick review, and then we'll hand it over to Marnie for a question and answer period. So let's get going on the first topic. Geodatabase Topology Basics. So you might ask, what is topology, and why is it important with GIS? It describes relative positions of map features. For example, connectivity, Highway 30 connects to Highway 61. You have adjacency, the land is adjacent to water. You also have a park that's contained within the city boundary here. So those are some examples of some spatial relationships in the real world that you might want to try to model in your data. So as far as GIS uses go, as far as analysis is concerned, all the analysis tools work the same whether your data has a geodatabase topology setup or not. The big thing you have with geodatabase topology is that you are able to maintain your data integrity by setting up a geodatabase topology. So let's go ahead and talk about topology in the geodatabase. It helps ensure spatial integrity or spatial data integrity. You can set up a number of user-defined rules, and this in turn will find or discover topology errors. You can fix some of these topology errors with tools that are in ArcMap, and we'll talk more about this in topic 3. So let's take a look at this image here on the side. We've got monument, lot lines, parcels, and zoning. You can see in this case, when you look at the monument, down here you see that it doesn't quite line up with the zoning layer, but it does line up with lot lines and parcels. In this case, you might want to set up a rule that looks for a situation like this where your layers are not lining up properly. That might be an example of how you can apply geodatabase topology. So it's based on coincidence. What this means is if you have two polygons next to each other, the line in between them is two lines directly on top of each other, or they're considered coincident within a cluster tolerance that's user-defined. It can be between one or many feature classes that are contained within a feature data set. So it's not persisted. It only stores properties, rules, errors in the actual topology class. And the topological relationships are discovered on the fly in ArcMap. And it might be a little different for those of you that are used to the ArcInfo coverage setup, where the topology has actually persisted with the data. But in the geodatabase topology, it's not persisted, it's discovered on the fly. So, speaking of licenses, you need ArcEditor or ArcInfo license to create and manage geodatabase topology. If you're working with an ArcView license, you can view the data or view the feature classes that participate in topology, but you will not be able to edit them or create a geodatabase topology class. So let's take a look at the geodatabase topology class. It stores properties like the participating feature classes, cluster tolerance, ranks, and rules. As you can see on the side here, we've got a feature data set called land base, and in there we have a couple feature classes. All the feature classes within one feature data set must have the same spatial reference. And this is also a requirement of the topology class for setting up a geodatabase topology. It must work with features that are in the same spatial reference. Therefore, that's why we must set up a topology within a feature data set. So, it also stores errors, exceptions, and dirty areas. And we're going to really get into these specialized features in topic 2, so I will hold off until then to explain them in detail. So during validation, all the feature coordinates that are within a certain defined cluster tolerance are considered identical, and they are therefore coincident geometry is established. And that enforces your topological relationships, or gives you the ability to enforce your topological relationships by the rules that you apply. So you might have, prior to 8.3, you might have worked with the shared edit tool or the integrate command with either shapefiles or geodatabase feature classes. And currently, with the software and geodatabase topology, these two functions have been rolled into a map topology tool, which works separate from geodatabase topology and can be used with any of our license levels, including the ArcView license. And this can, like I said, can be used with, these new tools can be used, the new map topology tool can be used with shapefiles or geodatabase feature classes, while geodatabase topology is only with geodatabase feature classes. So let's look at the topology process. When creating the topologies, there's many factors or properties we need to think about. Cluster tolerance and ranks are two that we're going to talk about in the upcoming slides, and then rules are something we're going to talk about in topic 2. So let's take a look at the cluster tolerance. The cluster tolerance is the distance in which coordinates are considered identical. As you can see here, any place where feature coordinates are within a cluster tolerance, they snap together during the validation process, creating coincident geometry. Things to know about the cluster tolerance is that it should be very small. If you don't know your coordinate accuracy, you should use the default value that comes up in the panel when you're setting up your cluster tolerance. If you do know your coordinate accuracy, I would suggest setting the cluster tolerance to about 1/10 of the coordinate accuracy. This means if your data is in 1/10 of a meter, you should set up, or your coordinate accuracy is to 1/10 of a meter, you should set up your cluster tolerance to 1/100th of a meter, which would be 1/10 of the coordinate accuracy. Some things to know about the cluster tolerance is it's not recommended for bulk data adjustments. So if you're using it to clean up your data, it's not a good idea, because if you set the cluster tolerance too high and snap too many features together, it might change things in your data that you were not looking to change. But it is, however, for ensuring topological integrity of your data. So we must mention ranks also. Ranks are how control how coordinates move during validation. So you have, down in the bottom here, we have two feature classes. We have feature class A and feature class B. In B, there's two features in feature class B in this example. Once we set up ranks, we can either set them up as equal ranks, where we have the ranks for B and for the feature class A as being equal, and this is set up between subtypes or individual features, they're not set up between subtypes and individual features. They are set up between feature classes. So it's just between feature classes. So A is one feature class and B is another feature class. If the ranks are equal, you're going to see that your crack points along A here is going to snap to an endpoint of B. So a crack point along a line will snap to an endpoint. And then if there's two endpoints involved, they will snap to an average location. As you'll see, if you set up unequal ranks, the lower ranked vertices will move to higher ranked vertices, 50 being the lowest and 1 being the highest. So you can see here, B1 is snapping to the crack point of A1, and B2 is snapping to the endpoint of A1. So let's go ahead and go into a software demonstration. I'm briefly going to show you some things, kind of the things we talked about in topic 1 here. So let's go into the just to the topology geodatabase. Let's take a look at the service or the assessor feature data set, and let's right mouse click on this topology class here and go into properties. You can see here that we've got some tabs for our topology properties. The general tab has the name of the topology, And you can see it has the cluster tolerance. One thing to note, the cluster tolerance is kind of long and kind of a strange number. The person that set up this topology has kept the default cluster tolerance, so that's why it looks the way it does. And let's take a look at the feature classes. And in the feature classes, we've got 3 feature classes that are involved in this topology, and then we have a rank of 1, 2, and 3. So that means our survey monuments are our most accurate layer. So our parcels and our lot lines, if there's any features within them that are in the cluster tolerance of one of the survey monuments, those features will move to the survey monuments. So we'll briefly take a look at the Rules tab here. The Rules tab just stores our rules that we've set up with this topology class, and we'll discuss this more in topic 2. And then our Errors tab. This is where you can actually generate a summary of the errors that come up after you validate the topology. And we'll talk in detail about this in topic 2. So I'm going to close this down now, and I'm going to go back into the presentation. And we're going to go through a short review here. What is topology? We talked about how it helps you maintain your spatial relationships from the real world in your geodatabase. And then topology in the geodatabase, it's based on coincident geometry. The Geodatabase Topology class is the actual object that physically stores your errors or your specialized features, and also what rules and the other properties of the topology. And then the cluster tolerance, dealing with which, the cluster tolerance is the tolerance of which feature coordinates are considered identical. And then ranks allow you to, during validation, snap certain features in one feature class, not subtypes or individual features, but features in one feature class to features in another feature class, and how the ranks are set. So let's send it over to Marnie here, and she's got a bunch of questions that she wants to answer.
Thanks, Ben. The first question here we have is from Jim in New Orleans, asking about how this topology model differs from this topology that we had in a coverage. And I know this is a question for a lot of our users who are coming from the coverage world of working with that data model, where the topology relationships were actually stored in those coverage tables. If you had a coverage of, say, parcels, if you looked at the feature attribute tables that made up that coverage, you'd actually see information about the spatial relationships. If you looked at the arc attribute table that made up the boundaries of those parcels, you'd see information about the to and the from nodes on the arcs that made up those boundaries. You'd see the ID for the left and the right polygon. So those relationships of connectivity and adjacency were actually stored in those tables. That's different when it comes over to our geodatabase topology model. You don't see that information in your feature class tables. That information, or those relationships, are determined on the fly when you're working with that data in ArcMap. So you can still do analysis, you can find adjacent polygons, you still have connectivity between features if you're working with like water pipes or different utilities, but it's not intrinsically stored in those tables. You have rules. We'll get more into this as Ben goes through the presentation. There's rules that you can set up about your geodatabase topology that offer you a lot more flexibility than your coverage model did. In a coverage, you probably didn't think about the fact that you had rules on that data, but you did. If you had polygons, you had a rule that each polygon had to have a label point. The arcs that made up that boundary had to be unique and connected. But now in our geodatabase topology, we're able to set up rules about the features in the same feature class, like parcels can't overlap or can't have gaps. But you've also got the added flexibility of having topology rules set between features in different feature classes. My building footprints can't overlap a parcel boundary, something along those lines. We also can work with different geometry types. We could have rules about points having to coincide perfectly on lines. So power points have to, or power lines have to connect perfectly to a power pole. So we'll see as we go through the presentation and Ben talks more about the rules, you'll see this flexibility over our coverage model. We also have a lot of questions here about the Cluster tolerance, how it's determined. Robert asks, how is the default cluster tolerance value computed? What are the parameters it's based on? Well, that cluster tolerance, that minimum distance that features need to be within to be snapped together to be considered coincidence and have that coincidence forced, have them snapped together, that's based on the precision of your data. So if you have data that's, your precision has been set maybe to 100. So if your data was in meters, you'd have down to centimeter accuracy. That cluster tolerance is the inverse of that precision. So you're going to get a very, very small number by default. So I think people get nervous when they hear that their features are going to be snapped together. You have to remember it's within a very, very small distance. We're talking possibly millimeters, so it's not affecting the accuracy of your data. So it is based on that precision that you store with a feature class in your geodatabase. Kent in Raleigh asks, how is that cluster tolerance, how is it similar to the fuzzy tolerance? Well, that fuzzy tolerance was one of the arguments that you had on the clean command when you were working with a coverage. So very similar, it is a distance that features, if they are within, they will be considered identical and snapped together. The difference with that fuzzy tolerance, though, on the clean command is that when it snapped, say, two small line segments together, it cleaned one off because you couldn't have two features in the same place. With our cluster tolerance, it's maintaining coincidence, so those two line segments would be snapped together and remain in the identical location. All right, Ben, I'm going to let things pick up with you here again and continue on with our geodatabase topology.
Well, thanks, Marnie. That was great. We got some good information there. Thanks for all the questions that everybody's sending in. Just keep them coming. When you think of a question, just type it in and send it to us, and we'll try to take a look at it. So we're going to start now with creating and validating a topology. We'll try to explain, or I will try to explain, a lot of these principles that we've just briefly touched on in the Geodatabase Topology Basics. We'll go in more detail. Let's go to the topology process again. You'll see that we're trying to create the topology here, and which we'll actually do this in the demo for topic 2. We've talked about cluster tolerance and ranks. Now we're going to go ahead and talk about rules. The rules are very important. It allows you to set up these, or model, or look for problems in spatial relationships in your data. So let's take a look at topology rules. They basically define valid spatial relationships. So one example might be monuments must be covered by an endpoint of lot line. You can see that they're in regular English, and you can see that for this example, you've got a monument here that is not covered by the lot line, so that would be considered an error. And we'll talk errors more later in this section, but a lot line must not have dangles is another example of a rule that models a spatial relationship. And also parcel must not have gaps. This is another rule that you might set in your data. So, just to briefly talk more about rules, there are a total of 25 rules that can be set. And they are all pre-made for you, and they can be either within one feature class or subtype, or they can be between feature classes or subtypes. So you can have point on line, point on polygon, line on line, line on polygon, or polygon on polygon. That's between feature classes or subtypes. And a couple things to note about these rules is they're created with the topology or set as properties. So you can create them when you create the topology, or you can wait and add them as a property. Or let's say you set up a bunch of rules and you decide you want to delete some of those rules and add some new rules because it's just not what you're looking for. This can all be done. With Geodatabase Topology, it's very flexible. So they're also checked during validation. In addition to the cluster tolerance going in and making your geometry coincident within the cluster tolerance, your rules are checked during validation. And then the violations from these rules are stored as errors in your topology class. So let's take a look at some examples of some possible rules. One example might be, must be properly inside. And this is an example that's between a point and a polygon feature class. Points in an address feature class. One scenario might be, points in a address feature class must be completely inside polygons in a parcels feature class. So you can see we have address points here, and then we have parcels. And once we apply the error, apply the rule and find some errors, we see that one of the errors here is completely outside of a polygon. That would be considered an error. And also we have a point here that is on one of the polygon boundaries, and that's also considered an error because it's not completely contained within, or it's not properly inside. So what can we do if we have these problems? We can go ahead and do some fixes. We can either delete the points or move the points to a new location if we know where they should be. So now I have a review question for you. It's a true and false question. The question is, you can only add a topology rules when you create the topology class. And the two options are true, which would be A, or B, which would be false. You can answer the question by clicking on the review question link on the left side of the interface and choosing the answer that you think is correct. We'll take a look at the results after a couple slides. So let's take a look at another example here. We've got a line rule example. The rule might be, must not have dangles. And the scenario could be a water pipe must be covered by at least one other water pipe end. And possible fixes for this error that would come up because of this rule would be a snap, trim, or extend. And these are fixes that are default in some of the tools to work with topology in ArcMap. And we'll see this more in topic 3. So let's take a look at a polygon rule example. The rule is must not have gaps, and this is within one feature class or subtype. The scenario might be no holes between adjacent vegetation polygons in the same vegetation feature class. So you can see here we've got a gap here, and if we go ahead and we apply or do the validation and find the error, we can see that we have an error there where the gap was. And to fix that, a possible fix would be create a new polygon. And one thing to note here is if you did create a new polygon, you'd probably want to go ahead and attribute it correctly for the vegetation feature class. And also some other examples of places where you might not want to have gaps would be soils or land use coverage, or land use feature class, or maybe a land cover. So let's get back to that review question. You can only add topology rules when you create the topology class, and the answer is false. You can actually add rules after the fact, so you can add them as properties, and you can also add or change the cluster tolerance, or add feature classes, or take away feature classes, or change the ranks, all after the fact through the properties dialog. As I can see here that it looks like we're kind of split in the answers that we came up. Half of you thought there was, oh, now it's changing. So it looks like most of you thought that the answer was false, which would be B. So that's great. So let's continue on with the lecture here. So the topology process. Once we've created the topology, which we'll do in the upcoming demo, the entire topology is considered a dirty area. And we'll describe those in the upcoming slides. And once we have dirty areas, we need to validate the topology. So we're getting close to the end of this flow, or actually there is no really end. It's kind of a cycle, or you can cycle back on this process. It's ongoing. You can kind of stop at any point. So let's take a look at dirty areas, areas that have not been validated. They may contain existing or undiscovered errors. The entire extent is dirty when the topology is first created. Another way you can get dirty areas is if you do edits to your features. So let's say you have a feature and you go ahead and edit that feature, and a dirty area is created. So the reason dirty areas are created is that only dirty areas are validated during validation. So this speeds up the process, because when you first validate the topology, you have to validate the entire extent. Why, if you just make edits or fix errors that in turn make edits on your features, it only validates those areas that you've updated. So we must talk about validation now. Validation is the snapping of coordinates using the cluster tolerance and ranks. It can be done in ArcCatalog or ArcMap. One thing to note, though, is if you're in ArcCatalog and you do a validation, you cannot undo. So unless you have a backup of your data, the way the features have snapped together during validation cannot be undone. However, in ArcMap, you do it in an edit session, so you can go in and you can undo if you don't like the way the features snap together by using the cluster tolerance. So let's take a look at what actually happens during validation. So before validation, we have the line right here that has a cluster tolerance around its endpoint, and it's within the cluster tolerance of this other line. So what happens is there's a crack point made on the closest location to that other line, and the cracking is the adding vertices to the line. And then the clustering process happens, which is snapping or averaging vertices. In this case, it looks like the ranks are equal, so the crack point of that line snapped to the other line that we have here, the horizontal line. And then the final, after validation, would look like this. One thing to note is that no new features are created. This is one line here, and then there's one line here. Only a vertex is added. This is a little different for those of you that are familiar with the coverage topology, where in this case, if you're doing it clean, which would be very similar, it would actually make 3 different features and not 2. But in Geodatabase Topology, no new features are created. So another thing that happens during the validation is the topology rules are checked, or the topology rules are applied, and they discover errors. And those errors, of course, are symbolized rule violations, and those are physically stored in the geodatabase or in the topology class. Different rules find different errors, and they're found during validation, and if there are no rules, if you do not set any rules, no errors will be discovered. So they're stored in the topology class as specialized features. One example might be a point error, you have some line errors, or a polygon error. And they do have properties. They tell you which rule is violated, and they also tell you which features caused the error. So there's a lot of detail involved. And this information is used by the ArcMap edit tools to do some default fixes of some of your errors. So let's go into a software demonstration now. We're going to go into ArcCatalog, and we're going to close down this assessor feature data set. We're going to close down actually the whole geodatabase, and then we're going to go into the create topology personal geodatabase, and then go into the service feature data set. And then we're going to right mouse click on that service feature data set, and then go to new topology. So in here we have the first opening screen that describes what you're doing and what a topology is. And then the next screen we have has the name for your topology. We're going to keep the name as service topology, which would be the default. And you can see the default cluster tolerance here is quite small, and I happen to know that the coordinate accuracy of my data is 1/10 of a meter. So as we talked about in the first topic, I'm going to change the cluster tolerance here to 0.01, which would be 1/100th of a meter, because that would be 1/10 of your coordinate accuracy. And I'm going to push next, and in this case I'm going to use just the buildings and the parcel feature classes in this topology. And then I'm going to push next, and then I'm going to set up some ranks, and since I have 2 feature classes, I'm going to put 2 for the ranks, and then I'm going to set the buildings as 2 and leave the parcels as 1, just because I know my parcels are more accurate than my buildings. And if there's any case where a building feature is within the cluster tolerance of a parcel, I want the buildings to move to the parcels. So I'm going to go next now, and I'm going to put some rules here. So I'm going to push the add rule button, and I'm going to go take a look at the feature classes I have here. I can either use the building or the parcel, but wait, there's a plus sign here in front of the building. And that actually means that you have subtypes. And like I stated before, you can actually set up rules, topology rules, between subtypes. So if I wanted to, I could use the house, garage, or yurt to set up rules rules with, let's say, houses. You could have a special rule where houses might something set up with parcels, so it would only be on houses, while you might have garage or yurt be exempt from that rule. It wouldn't apply to that. For example, might be a yurt is a recreational structure, and you might not be able to have water meters in certain states on yurts. So you might want to set up that water meters need to be on the boundary of houses or garages, but yurts would be an example where you would not want to set up that rule. So in this case, though, I'm going to use the entire feature class, all the features in the feature class building, and then the rule is going to be must be covered by, and the second feature class is going to be parcels. So in this case, we're going to undo the errors here so you can see what it looks like. The yellow would be the parcels feature class, and the blue would be the buildings. So in this case, this would only be the valid scenario that you could have if you had it where this would be the parcels and this would be the buildings. That would be an error because the buildings are not covered by the parcels, and same with this because it's just an overlap and you don't actually have either of them covering each other. So let's go ahead and click OK to this rule, and let's push the add rule again, and we're going to set up a rule now that's just with parcels. And the rule we're going to set up is must not overlap, because we do not want our parcels to overlap. Oh, I chose the wrong rule there. Let's try it again. Try it again. Maybe I'm moving too fast. There we go. Must not overlap. So this one's a little easier to see. We can click off the show rule errors and see that if your parcels overlap, that's when your error is going to be flagged or discovered. So let's click OK. Okay, there's two other things I want to show you on this dialog, and there's the load rules and the save rules. So we've set up these rules. We might want to save them out to an RUL file, and then once they're saved, we could maybe go into another topology or another geodatabase and load those rules in so we don't have to redo the rules. This can be very helpful if you have hundreds of feature classes or hundreds of rules you're setting up between different feature classes. So it's kind of a neat option. So let's go ahead and push next. This is just the summary that says the name of our topology is service topology. The cluster tolerance is 0.01 meters. We have feature classes, buildings and parcels. Buildings has a rank of 2 and parcels has a rank of 1. And then we have two rules that we set up. So let's push finish. Now it's going to ask me if I want to validate now. And I'm going to say no, I do not want to validate now, because I want to actually go in and show you what this topology class looks like in the preview once it's been created. You can see that the entire area is a blue hatch pattern, and this means that the entire area is a dirty area. So to get rid of that entire dirty area and discover some errors, we need to go down and validate. So once it's been validated, I'm going to refresh the database. There's the refresh option. Then I'm going to go back in and take a look at that topology. You can see that now I have two errors coming up. And let's go ahead and go into ArcMap, and I want to show you what happens when we add a topology class into ArcMap. So we're going to open ArcMap up, and we're going to push the Add Data button. And we see the service topology here. So we're going to go ahead and push Add. And it says, do you want to add all the feature classes that participate in service topology? And I'm going to say yes. So in this case, now we can see the topology in the side here. And we can see that we have errors that are drawing on top of our feature classes, our buildings and our parcels. You can see we have our subtypes here, but in this case that's not that important because we've set up the rules just between the feature classes and not the subtypes. So let's right mouse click on our topology and go into properties. So in this case we see we have a symbology tab, and then we can actually change and symbolize the errors by a certain color. So let's say we want to have our must be covered by and our must not overlap be of different colors. And there's another error that you haven't, or another rule that you haven't seen before here, and that's discovering a certain type of error. This is called must not be larger than cluster tolerance. What this means is that, and this is to look for slivers in your data. So any feature that is smaller than your cluster tolerance is flagged as an error, and this small feature then can be, you can go ahead and delete it. It's going to be marked as an error, so it's not going to automatically delete it for you. So it's a way of looking for these very small slivers that are smaller than your cluster tolerance. and it allows you to go ahead and delete those once you find them. So let's go into feature classes, and you can see it's very similar to ArcCatalog. You have the two feature classes and the ranks. And let's go in the Rules tab. You can see we have our rules here. And let's go into the Errors tab. And we talked about this briefly in the first topic. Let's go ahead and generate the summary. You can see that these are our errors in this in these feature classes, or with this topology. We have the must not overlap, we have one, and then must be covered by, we have one error. So that's an easy way, and you can export it to a file, which allows you to save it to a text file, so that's kind of a neat function. So I'm going to cancel out of this, and I'm going to cancel out of this, and I'm going to go ahead and go back into the presentation now. And we're going to talk about a little review and discuss what we went over in topic 2. We talked about the topology rules. There's 25 of them. We talked about that the topology rules model spatial relationships. We talked about if once you create your topology or you make edits, it's considered a dirty area. And we talked about validating our topology, and during the validation we find the errors. So the errors are discovered, and then they're stored as specialized features in the Geodatabase. So I'm going to turn over to Marnie now, and she looks like she has a long list of questions that you've been sending in, and she's going to answer some of them.
I do have a long list of questions. Thanks everybody for sending your questions in. We'll try and get through as many as possible. We have quite a few questions here that are similar. Carol in St. Petersburg, John, they have questions comparing geodatabase topology to map topology. Now, this is where our licensing comes into play too, which we also have a few questions. You know, what's available for ArcView users? Can they use this geodatabase topology? Now, to create the geodatabase topology, just like Ben did in the last demo, requires an ArcEditor or an ArcInfo license with the ArcGIS products. You still can view and query and work with feature classes that participate in a topology with an ArcView license, but you aren't able to set up the topology or edit those features. That's where you need the more advanced license of ArcEditor or ArcInfo. One thing you do have available, though, with an ArcView license is a map topology. This is something that is just created during an edit session. You can choose which feature classes participate. It might be feature classes in a geodatabase, or it might be shapefiles. You have that option as well with the map topology. So you can choose which feature classes participate, and then you have some editing tools to maintain coincidence geometry. You'll be able to move two shared boundaries together. So some basic editing tools with that map topology. And as I said, it's just within an edit session. Unlike this geodatabase topology that we've created here, is once you've set it up, it's available for anybody working with that data. We have questions here about about our cluster tolerance and moving our features. We have a question here from Slavko and Phoenix. In the validation process, are the actual source features being cracked and moved, or is it only in the topology layer? No, it's actually in the data itself. So those features that are within that cluster tolerance are being moved in the actual feature classes. But again, remember, it's within that very small cluster tolerance. They're just being moved, you know, sub-units of your map units, just a very small amount. They're being snapped together to force coincidence. Matt in West Bend asks, when the cluster tolerance is applied, does the user have any control over how the features are snapped? That's something that we control through the ranks that we set on the data. So if you have one feature class, say you've got parcel boundaries that were collected through a very accurate survey, you would probably give that feature class a rank of 1. If you have other data that participates in your topology that's not so accurate, maybe it was digitized, you would give that information a lower rank so that when you ran the validate, those less accurate feature classes would snap to your more accurate data. You can also have data that has the same rank. Maybe it's all sort of equal in its accuracy. In that case, there was, say, a gap between two lines that should have been snapped together. Those two endpoints will move to an average location. But again, within that cluster tolerance, it's going to be a very, very small amount that they move. Bernd has a question here. Can topology rules reference attribute values? Well, our topology rules can be set for all of the features within a feature class, or they could be set based on a subtype. So if I had a feature class of water mains, I probably have different types of water mains within that feature class, and they are differentiated by the subtype, which is based on an attribute value. Maybe a 1 is our main lines, a 2 is laterals. So based on that attribute, you can set your different rules. Maybe main lines can connect to other types of pipes where laterals couldn't. So in that way, you would be able to look at the different types of features, create subtypes on those features within a feature class, and then apply your topology rules. So Ben, I'm going to let you pick it up again here. We're going to take a look at editing.
Yeah, let's go ahead and go into the next section here for editing features. Actually, I'm going to address one question really quick before we go in, and Thomas from Middleton asked, can you have exceptions to the rule? And as you're going to find out in this next topic, that yes, you can make exceptions to any of the rules. So you can mark them as exceptions, and we'll talk about that in topic 3. So let's go into editing geodatabase topology. So we'll go back to this topology process slide, and we've done a lot of work in setting up our topology and validating it and finding some errors. Now what can you do once you find errors? What can you do? So we've got dirty areas here, of course, when either we make edits or the topology is created, and then we validate the topology, and then there's 2 ways we can go. We can either go and maybe edit some features if we decided we need to edit some of our features, do some topological edits or any edits to any of the features you have. That'll make a dirty area, and then we'll need to validate again. Another thing we can do is if we've done a validation and we see that we have errors, we can either fix the errors or make exceptions. If we make the exceptions, we can go ahead and the exceptions will be stored in the topology class itself as a specialized feature. If we do fix any errors, we go over here and go back to the dirty area again, and then we have to validate, and then we might find other errors, or we might say that we have no errors, and then we can go ahead and do our analysis or do whatever we need to do with our data. So let's go ahead and talk about managing errors. There's a couple options you can do. You can ignore the error. Just because you have errors in your topology class does not mean that your data is not usable for analysis. You can mark as an exception. You can mark the error as an exception, and then it's stored in the geodatabase and for our geodatabase topology class. So from then on, your error is considered an exception. It will not be flagged as an error. So you can fix the error, and fixing the errors can happen with the topology toolbar or the editor toolbar in ArcMap. And one thing to note is that you cannot delete any errors. You can only mark them or fix them as an exceptions, which is kind of nice because what you're doing is fixing the problem, not just covering it up by deleting the error. So it's kind of a nice option. So let's talk about some of the tools that we can use to fix errors. One would be the error inspector. And this has many standard fixes for rule violations. It's a neat dialog because it allows you to view multiple rules at the same time, or multiple errors that are violations of the rules. As you can see here, you've got the visible extent only checkbox, which you can either have on or off. If it's checked on, only the errors that you're zoomed into will be shown in the error inspector, and if it's clicked off, you'll see all the errors in your extent. So let's say you have an error here, must not have dangles. You can select these 5 errors and then right mouse click and go in and see some of the standard fixes, and also the option to mark it as an exception. And we'll see this more in the demo for topic 3. So if you want to manually fix errors, there's another tool you can use called the Fix Topology Error tool. This is very similar to the error inspector, but allows you to visually go in, select an error, then right mouse click, and you can either use some of the default fixes or actually see the error, because maybe you don't know why this error is coming up, and show the rule description, or you can also mark it as an exception. So if we've talked a little bit about fixing errors, but let's say we just want to do some edits that maintain the topological relationships. If you're editing feature classes that participate in a topology, you're actually going to edit the topological edges or nodes. An edge is a single line or polygon boundary or a shared part of coincident lines and or polygon boundaries. And a node is a vertex at the end of an edge or a vertex located where features intersect. So what this allows you to do is you might edit this edge, which is the shared feature between these polygons, and when you when you edit the edge directly, you are indirectly editing the features underneath. So you're moving all the polygon boundaries or all the lines that are participating or in that edge, that are in that coincident setup. And you can also drag the nodes. If I edited this node here and dragged it downward, you'll see that all the features were rubber band, maintaining that topological or that coincident geometry. So let's take a look at some of the tools you might use when you're doing coincident geometry editing. You can use the Show Shared Features tool, and what this does is allows you to, in this case we've checked off zoning, so certain features in the zoning feature class you do not want to move when you edit the edges that make up parcel lines, parcels, and also zoning, but you've disconnected zoning from the topology temporarily. Another tool that you will use probably a lot will be the Topology Edit tool. This allows you to select and modify edges and nodes. So you click on an edge, you can drag it to its desired location, and then once you release, you'll see that it's still connected to the topology and all the features rubber band along with that movement. And the E key and N key are good keys, or hotkeys you might call them, to know when you're using the Topology Edit tool, because an E key will allow you to select edges and an N key will allow you to only select nodes. So let's go over a couple techniques here. You can move polygon boundaries without creating slivers using the function that we're going to talk about here with the Topology Edit tool. So you select one node and one edge using the N and E keys, and then use the S key, which is the hotkey for splitting, and this splits the node from the edge. Then you're able to slide it along and then reconnect it. And the key is here that the edges that are normally connected to that node do not rubber band when you make this topology edit. So it's a nice function, let's say if you're moving lot lines or parcel boundaries. So let's take a look at another editing technique, splitting an edge, where in this case you select an edge and then you have an option to temporarily split the edge or put it in a topological node. You can see in this case we've split the edge at the anchor. Two other options would be splitting the edge along a line, either by a distance or a percentage. Once you've split the edge, you can select and modify one of the edges. So you're moving the left side of the line here, and you'll see that all the polygons are modified. There's a rubber banding effect. And then once that's done, you can click off from where you're editing and then rebuild the topology cache, and you'll see that the temporary nodes are removed. Temporary nodes are the circles here. They represent unselected topology nodes. Then you'll see that you have one continuous feature when you're done. So let's go into a demo and talk about some of the stuff that we've discussed in topic 3. So I'm going to go into ArcMap now, and I have a bunch of errors. I've validated my topology and I see that I have errors, and I'm in edit mode. I'm going to go and zoom in and check out some of these errors here. So I've got 4 different errors, and this time I'm going to use the error inspector to take a look at them. So I see that I have the error inspector clicked on visible extent only. I'm going to use the search now option to get all the errors from all the rules, and you'll see that I've got 4 must not have dangles. I'm going to hold the shift key down and select all of them. And you can see here that in this case there's only one feature class that's involved, but you can have 2 feature classes. And then you can have the shape, which has what type of shape it is, and then also which feature is involved in the topology. And then you can also, if you set it as an exception, you can see that it's set as an exception. So let's go ahead and let's close the error inspector and take a look at these errors. You see they're selected in black. So let's go back into the error inspector. Let's right mouse click on one of the selected errors, and let's go down and let's take care of these errors. And let's use the extend option to extend these dangles so they meet up with the other lot lines. And I know for a fact that I've gone in and measured, and the maximum distance that you would need to extend would be 30 meters. So So I'm going to click that, and you'll see that all the errors disappeared. You notice that there's some other errors here in the extent, and you can see just barely, you can see them underneath here. These errors are errors that are coming up from the dangles, but will actually be fixed by me fixing the dangles, and they still show up in the error inspector here, but once we validate, you'll see that they'll disappear because they're no longer an error because we fixed that problem that was causing the error. So let's close that down, and let's zoom to full extent here, and then let's zoom into this point error down here, and you'll see that it looks like in this case it's a water meter, and it does not have a building, so there's no building that can cover that water meter. Let's go ahead and let's right mouse click or select it, and then right mouse click with the Fix Topology Error tool, and go down and see if we can show the rule description. And like I was saying here, the boundary of the building is not covering the water meter, so this would be flagged as an error. In this case, I know that there's being a building built here, and we just don't have the floor plan yet or the footprint. So what I'm going to do is right mouse click on this error and go down and mark as an exception. So then the error disappears. So I'm going to zoom to full extent, and then I'm going to zoom into this other point error that I see. And this looks like the same kind of error, but I'm going to use the Fix Topology Error tool and go in and just make sure that that's the problem. And yes, if the problem is it does not have a building covering the water meter. So, as you can see here, all these other water meters are right on the edge of the buildings. So in this case, I happen to know that this eventually this water network will connect to another, or this network will connect to another network. So this is a meter that's kind of in air. It must have been digitized incorrectly. So I'm going to go in and I'm going to select it, and then I'm going to go ahead and delete the feature underneath, which deletes the error. So I didn't physically delete the error, I deleted the feature, and then the error disappeared because it was no longer an error. So I'm going to zoom to the full extent now, and we're going to do one more error fix. You can see we have one more error here. And this, you can kind of see what the problem is, but I'm going to go in and use the show rule description, and yes, it must be covered by is the rule that's being violated, which means this building must be covered by this parcel feature and cannot extend into another parcel. So in this case, I'm going to go in and grab the edit tool, then I'm going to double click on the boundary here and to expose the nodes. And then in this case, I do not have the snapping tolerance set up, but I'm just going to move the building so it's contained completely within one of the parcels. And normally I'd want to set up a snapping tolerance and probably snap the building right to the parcel line, because in this case I believe it's supposed to be right on the parcel line. So I'm going to zoom to full extent now, and you can see that error still exists even though we fixed the problem. So let's go ahead and do the validation process. We're going to validate for the full extent because we have a very small extent and it will not take a while. So I'm going to push yes, and now you see that the error has disappeared. Now if you go into the error inspector, you'll see that once I search for the full extent, you'll see that there's no errors. So those other errors that were fixed by the dangles are now gone. The one thing I do want to show is that if I click on the exceptions tab, I can find that exception that I made. So that is stored in the Geodatabase now. So I'm going to click close to this dialog, and we're going to do one more thing in this demo. We're going to zoom in, and we're going to do a coincident geometry edit using the edit topology tool. So we're going to go down now and select this parcel boundary right here, and right mouse click, and we're going to split at edge at a distance. I know for this example we need to move this parcel boundary by 30 meters, so I'm going to choose that in the dialog here. And then what I'm going to do is I'm going to use the E key to select this edge, and then use the N key to select the node. Then I'm going to use the S key, which will split the node away from the edge, and then I'm going to move it. And I'm going to click off where I was editing, and that rebuilds the topology. You'll see now that you have it's split, and you have two different edges here, and you've moved the boundary. So now I have the parcels edited, and you'll see also if I click or turn off the lot lines, you'll see that the underlying polygons underneath have also been moved. So by moving that topological edge, you're indirectly editing the features underneath. So that's going to end it for the demo for topic 3 here. Let's go back into the presentation and do a little review of what we talked about. We've talked about topology editing workflow. We talked about some of the tools you might use in error editing. We talked about how you edit edges and nodes when you're editing a topological, or when you're editing a topology, which in turn is editing the underlying features. And we talked about what tools you might use and what some methods you might use to edit coincident geometry. So that being said, I'm going to turn it over to Marnie because she's got some final questions she wants to answer.
Thanks. First question we have is from Michael in Utah, who's obviously using Enterprise Geodatabase. He's curious, are there differences in topology rules for the personal geodatabase versus the Enterprise Geodatabase? And no, there aren't. The 25 rules that are available apply to both the personal and the Enterprise Geodatabase. Another related question was, can I set up this geodatabase topology on a version feature class? And you can. So if you have, parcels feature class that's versioned, maybe you've got one that's, the actual parcels and one that includes proposed development, both of those would participate in a topology, and you would just see the edits that applied for the version that you were working in. Another question here from Caroline in Dallas. When do I have to validate? And as Ben said, the process is really quite cyclical, that you can work with your data, do edits, validate at that time, or you can shut down for the day, come back, validate at another time. So it really depends on your workflow. Some folks are going to run that validate every time that they're in an edit session, at the close of their edit session. Some might hit the validate after a few edits and make sure that they're not making any errors as they go along. So it really depends on your workflow. You aren't forced to validate at any time. You can still use that data. It might even have errors in it. You can still display, do queries. You can use that in analysis. So you have that flexibility over choosing the appropriate time for the data that you're working with to run that validate. Is there a way to back up inside the topology? This is a question from Dan. In other words, undo a topology if too large a cluster tolerance was used. There certainly is if you're running that validate within ArcMap. If you're doing it in ArcMap, you're going to be within an edit session. You're going to be able to hit the undo button if maybe your cluster tolerance was set a little too high and you see data changing that you didn't intend. If you run that validate in ArcCatalog, there is no undo over in ArcCatalog. So you need to be very careful about that cluster tolerance. And take a look at your data and make sure that you've chosen appropriate cluster tolerance. Because even if you're in ArcMap and you validate, the changes might be so subtle or someplace else that you're not currently viewing. You want to be quite careful with choosing the appropriate cluster tolerance. If in doubt, take the default value so that it's just a very, very small amount that your data will be snapped within. Question here from Mike. Can you check shapefile topology with the same validation rules? And no, you're not able to do this. The validate command works only on either our personal or our enterprise geodatabase feature classes that are participating in that topology. You can use that map topology tool to work with coincidence features that are part of a shapefile. And we've gotten quite a few questions on that map topology. We actually did a live training seminar a few months ago on that map topology, and now it's available as a web workshop working with map topology in ArcGIS. If you have further questions, if you're working with an ArcView license and you want to see what's available for you, you might want to check out that web workshop. And we're running out of time here. We're going to have to wrap up. Thanks everybody for their questions. I'm going to pass you back to Ben.
Okay, thanks, Marnie. That was great. That was some good questions that everybody's sending. Good questions that everybody is sending in out there. So, I'd like to talk about For more information slide, we've got a couple virtual campus courses that you might be interested in, especially the creating and editing geodatabase topology for ArcEditor and ArcInfo. It's a great course going over the geodatabase topology, a lot of things that we talked about today, kind of in a different light, so it might be a good thing to look through. Creating, editing, and managing geodatabases for ArcGIS 8.3. Another thing that Marnie mentioned is that live training seminar that's archived about map topology, for those of you who are interested about map topology. And also our ESRI instructor-led training course, Building Geodatabases, where we spend a good amount of time going over geodatabase topology. And then we have a product book. And in that product book, the Geodatabase workbook, we have a tutorial in there that goes through just a simple setup of a topology, so it might be a neat thing to run through. So if you want any more information about any of these or some other information, go ahead and click one of the icons below and you can get more detailed information. So on behalf of ESRI, I'd like to thank you all for attending.